Hello and welcome back to the channel. In this video, we're going to be building a job tracker application and we're going to be using the MERN stack. For the front end, we're going to use React, and to apply styling and responsiveness, we're going to use Bootstrap. And to create our server for the backend, we're going to use Node.js and Express. And finally, for the database, we're going to use MongoDB to store user information and their jobs. If you need any of the assets that we're going to use in this project, you can find them in the description below. So this is what the final project is going to look like. We're going to have our landing page, and in our landing page, we're going to have a description about the job manager. And we're going to have buttons to sign up and to log in. So we can press on the sign up button, which is going to give us a form. We can fill out this information and we can sign up. Initially, we're not going to have a job, but what we can do is using this form, we can add a new job. For example, for the company, we can put in Google, and for the position, we can put in Backend Engineer, and we can press on the add button, which is going to create a job, and we can edit this job using the edit button. For example, we can set the status to interview and press on the edit button, which is going to update the status. We can also press the edit button and delete the job, which is going to remove it from our database. We're also going to have a login functionality, so we can log out from this account and we can log in to another account. And when we click on login, it's going to take us to that specific account, which is going to have its own set of jobs. First, we're going to start with the backend. So we're going to head to our terminal. And we're going to create a new folder called Backend. And we're going to navigate to that folder. Now to initialize our backend or to initialize a node project, we're going to use the command npm init. Now it's going to ask us for the package name. We can use the default value, which is going to be the same as our folder name. For the version, we're going to use 1.0.0, which is the default value. The description, we're going to leave it empty. For the entry point, we're going to use the default value, which is index.js. For the test commands, we're going to leave it empty. The Git repository, we're going to also leave it empty. Keywords, we're going to leave it empty. For the author, you can put in your own name, but for now, I'm going to leave it empty. And for the license, we're going to use the default value. And finally, it's going to ask you to confirm the information that you've put in so far. We're going to press enter. And now if we go to our backend folder, we can see that a new file called package.json has been created. So we can look inside this file. So as you can see, all the information that we've put in so far is going to be stored inside the package.json file. Now the next step is going to be installing the dependencies that our backend is going to need. So to do that, we're going to head back to the terminal. To install a dependency, we're going to use the command npm install. And the dependencies we're going to use for this project are going to be bcrypt.js, cores.env, express async errors, http status code, JSON web token, mongoose, and finally nodemon. Before we continue, let's break down how we're going to use each dependency. So the first one is bcrypt.js. We're going to use this dependency to encrypt our passwords so we don't store the actual password the user enters in our database. The next dependency is cores. This is going to be used in order to make our backend accessible to our front end. .env is going to be used to store private information like our API keys. We're going to use express to create our server, and we're going to use express async errors to handle our async functions automatically. We're going to see how this works later on. The next is HTTP status codes, which we actually misspelled, so we're going to add a D. So we're going to use this package to use predefined status codes, so we don't have to memorize the different numbers. Next, we have JSON web token. We're going to use this package to create tokens and to provide it to the user for authentication. We're going to use Mongoose to communicate with our database. And finally, nodemon is going to automatically restart our server whenever we make changes. So once that's done, we can press enter. Now if we go back to our package.json file, we can see that under dependencies, we have all the dependencies that we just installed. One more thing we're going to do in the package.json file is add a script. So next to the test key value pair, we're going to add a new one, and the key is going to be dev, and the value is going to be nodemon, followed by our entry point, which is index.js. Now when we run npm run dev, it's going to start our server using nodemon. The next step is going to be creating our entry point. So we're going to head back to our backend folder. In our backend folder, we're going to create a new file called index.js. And in here, we're going to create our server. And as we said, to create our server, we're going to use the Express package. So the first thing we need to do is import Express. So we're going to have const express, and we're going to require Express. Once Express is imported, we can use it to create our application. Now, if you've seen the previous videos in this playlist, the only thing we're going to define in our index.js file is a start function, which is going to get called when we want to start our server. Once our server has been created, we need to listen to a specific port. And to do that, we're going to use app.listen, and we're going to pass in the port number. In our case, we're going to use 3000. Now this listen function can take in a second argument, which is going to be a callback function that executes whenever we successfully listen on port 3000. So in our case, the callback function is simply going to log server is running. So this is a basic server setup using Express. So to test this out, we can go to the terminal, and to run our server using nodemon, we're going to use the shortcut npm run dev. As you can see, we get server is running. That means our Express server is working correctly. The next thing we need to do is define the different routes that our front end is going to use. If you've seen the previous videos in this playlist, we've been defining our routes in a different folder. So we're going to head to backend, and we're going to create a new folder called routes. Now in this application, we're going to have two types of routes. The first route is going to be used to authenticate the user, and the second route is going to fetch the different jobs that is associated with a specific user. So this means we're going to have two files, one for the authentication and another for the jobs. So we're going to create a new file called auth.js, and we're going to create another file called jobs.js. First, we're going to work on the authentication route. The first thing we need to do is import Express. Next, we need to define an Express router. We can do that using express.router. So to authenticate a user, we're going to have two routes. The first is going to be a post route, and the path is going to be /login. Now the post function is going to take in an additional callback function that executes whenever the user goes to this path. In our case, we're going to define this function in a different folder. For now, we're simply going to put in the function name, which is login. The second route we're going to have is also going to be a post route, but the path is going to be register, and the callback function is also going to be called register. Now we haven't defined these functions yet, but we're going to define them later on. The final step we need to do is export our router. So we're going to have module.exports, and we're going to set it equal to router. Next, we're going to work on the jobs route. Again, we need to import Express, and we're going to create our router. To provide all the CRUD operations, which are create, read, update, and delete, we need to create 5 different routes. The first one is going to be a get route, and the path is going to be a /, and this path is going to get us all the jobs associated with the user. Again, the callback function is going to be defined in a different folder. For now, we're going to just put in the name, which is going to be get all jobs. The second route is going to also be a get route, but this time is going to take in a route parameter, which is an ID. And based on this ID, we're going to fetch a single job. So the callback function is going to be called getJob. The next route is going to be a post route, and the path is going to be a slash. And this route is going to be used to create a new job. So the callback function is going to be called createJob. Next, we need a route to update a single job. So we're going to have router.patch. And since we are going to be updating a single job, we need the ID associated with that job. And the callback function is going to be called updateJob. Now the final route we're going to need is to delete a single job. So we're going to have router.delete. And again, we need the ID of the job that we want to delete. And the callback function is going to be deleteJob. Once all this is defined, the final step is going to be exporting the router. So we're going to have module.exports, and we're going to set it equal to router. The next step is going to be defining all the callback functions associated with each route. As we've seen in the previous videos in this playlist, we're going to define these callback functions in a folder called controllers. So we're going to create a new folder in our backend, and we're going to call it controllers. Again, we're going to have two types of controllers. One is going to be associated with authentication, and the second is going to be associated with the different jobs. So we're going to create a new file called Auth.js, and we're going to create another file called jobs.js. First, we're going to work on the authentication controllers. In here, we're going to define two controller functions. One is going to be for the login and another for the register. So we're going to have login. Later on, we'll see why we need to define this controller as async, but for now, it's going to be a normal callback function, and it's going to take in a request and a response as input. And now, since we're only going to be testing if these routes work, we're simply going to send back a response that says login route. And the second callback function we need is the register callback function. Again, it's going to take in a request and a response. And for now, we're going to send back register route. The next step is going to be exporting these functions. So we're going to have module.exports. When we're exporting more than one component, we need to use curly braces. So we're going to have login, comma, register. Next, we're going to work on the jobs controllers. In here, we need to define 5 callback functions. The first one was getAllJobs, which is going to take in a request and a response. And for now, we're simply going to respond with all jobs. The second callback function is going to be getJob, which is also going to take in a request and a response. And we're going to send back single job. The third callback function is going to be for creating a job. So we're going to have createJob. And we're going to respond with createJob. Again, we're using these default values to test out the routes. Later on, we're going to define each functionality. The next one is going to be for updating a single job, which is also going to take in a request and a response. And we're going to send back updateJob. Now the final callback function is going to be to delete a job. So we're going to send back deleteJob. Now the final step is going to be exporting these functions. So we're going to have module.exports. Again, we have multiple components to export. So we're going to use an object and we're going to pass in all the functions. Once that's done, we're going to save this file. And next, we're going to import these callback functions in the routes. So first, we're going to head to our authentication route. In here, we're going to import the login and register callback functions. And we're going to import them from the parent folder, and we're going to head inside controllers, and we're going to head to the auth file. Next, we're going to go to the jobs route, and in here we need to import the 5 callback functions, which are get all jobs, get job, create job, update job, and delete job. And we're going to import them from the parent directory. Inside controllers, we're going to access the jobs file. So now we can save this file, and our next step is going to be testing that each route works correctly. Before we test out our different routes, we need to head back to our entry point and import our different routers. So the first router we're going to import is the authentication router, and we're going to require it from the routes folder, and we're going to access the auth file. The second router we're going to need is the job router, and we're going to require it from the routes folder and the jobs file. Now, in order to use these routers, we're going to use the app.use function. So we're going to have app.use, and in here we can provide 2 arguments. The first argument is going to be a path that we want to apply this router to. In our case, for the authentication route, we want it to be applied if the route starts with /API /v1/auth. So how this is going to work is the second argument, we're going to give it the router. And now if the user goes to /API /v1/auth/login, they can access our login route. And if they go to /register, they can access our register route. Next, we need another app.use for our jobs route. And for this one, the base path is going to be /API /v1/jobs. And for the second argument, we're going to give it job router. So how this is going to work is the user goes to /API /v1/jobs. And if they go to the root, they can either send a get or a post request. If they send a get request, they're going to get all the jobs. If they send a post request, they're going to create a job. And if they want to get a single job, they can pass in the ID, and they can get a single job, update a single job, and delete a single job. So once we've set up our routers, we can save this file and make sure that our server is running inside the terminal, and we can test our different routes. Now to test the routes, we're going to use the Postman extension. If you don't have it yet, you can go to the extensions tab, and you can search for Postman and download this extension. Once the extension is installed, you're going to see the Postman logo on the left panel, and we're going to open it up, and we're going to click on New HTTP Request. Now in here, we can test our routes. First, we're going to test the authentication route. So we're going to have HTTP localhost. Our port number was 3000, and our base URL for authentication was /API /v1/auth/login. Now we set this route up as a post route, so we're going to change our action to post. And if we send this request, we get login route returned. Again, we can check for register. And if we send this request, we get register route. Next, we're going to test the routes associated with jobs. And the base path for that was /API /v1/jobs. So first, we're going to send a get request. This is going to get all the jobs. So we get all jobs returned. Next, we can send a post request to /jobs. This is going to create a new job. So if we send this request, we can see create job. Another one we can test is a get request to get an individual job. So we can pass in an ID. And if we send this request, we get a single job. We can also send a patch request, which is going to update a job. So we get update job. And finally, we can send a delete request, which is going to delete a single job. Now that we know all the routes work correctly, the next thing we're going to try out is what if the user goes to a route that we have not defined. So let's say they go to /hello. And if they send a GET request, we're going to get this long error message. Now instead of this, we can define our own response to when the user goes to a route that we have not defined. And in order to do this, we need to define our own middleware. So a middleware is a special type of function that is going to execute before the server sends back a response. So in our case, when we define a not found middleware, it's going to go in between the request and the response, and it's going to send our custom response instead of the response that we just got. So we're going to head back to our backend folder, and by convention, we store our middlewares in a folder called middlewares. So we're going to create a new folder. And in here, we're going to create a new file called notfound.js. So as we said, a middleware is simply a JavaScript function. So we're going to define a notfound function. One thing that makes it different is that it's going to take in 3 arguments, a request, a response, and a next function. Now we've seen request and response before. So a request is sent by the user, a response is sent by our server. So currently our not found middleware is taking control of our application. So what the next function does is after we've finished our operations, it's going to pass the control to whatever comes next. But in our case, since we're going to be sending a response from our middleware, we're not going to be using the next function. In here, we're simply going to respond with a message that says route not found. Now we can also attach a status code. Now in the beginning of the project, we installed a package that lets us use status codes. So we're going to import that package. So we're going to import status codes, and we're going to import it from HTTP status codes. Now in here, instead of putting in a number, we can have status codes dot, and we get access to the different types of responses. In our case, we need the not found status code, so we can pass that in. So as you can see, we don't need to memorize the status code for not found. We can simply pass it from the status codes package. Now the final step is going to be exporting this function. So we're going to have module.exports, and we're going to pass in not found. Now we can save this file and head back to our entry point. In here, we're going to import the not found middleware. Once we've imported it, we're going to use it using app.use. So we're going to have app.use, and we're going to pass in not found. Now the placement of this app.use matters. So what we mean is first we need to check for the routes that we have defined. And if the user passes a route that doesn't match the routes that we've defined, then we're going to use the not found middleware. So to test this out, we're going to head back to Postman. And now if we go to /hello and send a request, and now we get the custom message which says route not found. We can also look at the status code, which we did not provide directly, but we can see that we have a 404 not found. The next part of our project is going to be associated with errors. Now Express has its own error handler, but in our case, we're going to define our own. And before we start defining our own errors, we're going to look at the Express async errors package, which we installed at the beginning of the project. Now to use this package, we're going to have require, and we're going to pass in Express async errors. Now in previous videos, when we defined our async controllers, we had to include try-catch blocks, but when using this package, it's going to automatically handle our try-catch blocks, and when we have an error, it's going to take that error and it's going to pass it to our error handler. Now we can start working on our errors. The first thing we're going to do is create a new folder called errors. And in this project, we're going to handle 4 different types of errors. The first one is going to be a bad request error. The second one is a not found error. We're going to see how these errors work when we use them later on in the controllers. The third one is going to be unauthenticated error. And finally, we're going to have a custom API error, which is going to be the parent class to all our other errors. So first, we're going to work on the custom API error. In this file, we're simply going to create a new class, and we're going to call it custom API error. And it's going to extend from the built-in error class. Inside the class, we're going to have a constructor. Now this constructor is going to be called whenever we create an object using the custom API error class. In our case, the constructor is going to take in a message as input, and it's going to pass this message to the error class. Now to access the parent class, we're going to use the keyword super, and we're going to pass in our message. And finally, we're going to export the custom API error, and we can save this file. So this custom API error is going to be associated to all the errors that we're going to come across when using our API. Now this is a general class that is going to represent the custom errors that we want to handle when the user is accessing our APIs. The remaining 4 errors are going to be specific. So first, we're going to head to the bad request error. In here, we're going to first import the status codes. We're also going to import our custom API error, and we're going to define a new class, and we're going to call it bad request error. So we're going to use this whenever the user sends a request, but the information that they provide is not the one we're looking for. So this class is going to extend from our custom API error. And we're going to have our constructor. Similar to before, it's going to take a message, and it's going to pass that message to the parent class. Now, what makes this specific error different is that we need to define a status code that is going to be associated with a bad request. So here we're going to use the this keyword. Now this is going to point to whatever object we create using this class. So we're going to have this.status code, and we're going to set it equal to status codes dot bad request. And finally, we're going to export this error. Once that's done, we're going to go to the next error, which is not found. Again, we can copy and paste since we're going to have similar code. We're going to copy the bad request error, and we're going to paste it in. And instead of bad request error, we're going to have not found error. And we're going to use this class when the user tries to access a resource that does not exist. So we need to change the status code. Instead of bad request, we're going to have not found. We're also going to change the export to not found error. And the final error we're going to be working on is the unauthenticated error. Again, we're going to paste in the previous code, and instead of bad request, we're going to have unauthenticated, and the status code is going to be unauthorized. So we're going to use this class when the user is not authenticated, and when they try to access a resource, we're going to tell them that they are not authorized. And for the export, we're going to pass in unauthenticated error. Now, before we move on to the next section, there's one more thing we can do. Currently, if we wanted to import different errors in our file, we would have to use separate lines. For example, if we wanted to import the not found error, we would have const not found error, and we would have to require it from the errors folder and from the not found file. And again, if we wanted another error, we would have another line. For example, we would have bad request error, and we would have to require it from a different file. But our life would be much easier if we could import all the errors that we want using a single line. So what we want to achieve is having const, then we would provide an object, then we would give it not found error and bad request error, and we would require it simply from the errors folder. Now we can achieve this functionality by defining an entry point to our errors folder. To do that, we're going to create a new file called index.js. In Node, the index.js file is a special type of file. It's always going to be considered as the entry point to the directory it's in. So what we can do is import all our errors into this file and export them again. So once we've imported all our errors, we're going to have module.exports, and using an object, we're going to pass in each error. So now what we can do is simply have const, and we can pass in an object, and we can pass in all the errors that we need, and we can simply require them from the errors folder. As we said before, Express has its own error handler, but since we're going to be handling our own errors, we can define our own error handler. To do that, we're going to head to our middlewares folder. Inside this folder, we're going to create a new file called errorhandler.js. And in here, first, we're going to import the status codes package. And we're also going to import our custom API error. So we're going to have custom API error. The reason we only need to import the custom API error class is because it's the parent class to all the other errors that we defined. Since we set up the index.js file, we can simply pass in the errors folder. And next, we're going to define our error handler. As we said, a middleware is a JavaScript function which takes in 3 arguments, a request, a response, and a next function. But to define a custom error handler, we need to provide an additional argument, which is error. Now inside our handler, we're going to check if the current error is an instance of our custom API error. So if it is an error that we're trying to handle on our own, we're going to return a response with a status. Now, since we've defined a status code associated with each error, we can access it using error.statuscode. And we're going to have a JSON response, and we're going to return whatever the error message is. Now, this is going to be executed if the error is either a bad request, a not found error, or an unauthenticated error. Now, if this is not the case, and if the error is something that we have not expected, we're going to have another return, and the status is going to be status codes.internal server error, and we're going to return a JSON with the error. So how this is going to work is if the error is one of the errors that we've defined, then we're going to access the status code associated with that class, and we're going to return the message. But if the error is not part of the custom classes that we defined, we're going to have a general response. Finally, we need to export the handler, so we're going to have module.exports, and we're going to pass in error handler. Now to use this, we need to head back to our entry point, and we're going to import it, so we're going to have const error handler, and we're going to require it from /middleware/error handler. And to use it, we're going to have app.use, and we're going to pass it in. Before we move on to testing our custom error handler, we're going to go back and fix a small issue. Now the issue is that we didn't use the correct path, so we're going to have .. Then we're going to pass in the errors folder. Now to test this out, we're going to head to one of our controllers. So let's say we head to the jobs controllers. And inside the getJob controller, we can access the ID from the request using request.params. So to test the error handler, we're going to check if ID is 123. We're passing this as a string since by default, request parameters are strings. So if that is the case, we're going to throw a new error. And let's say we throw the bad request error. Now, since we provided a constructor, we need to provide the message. For now, we're going to set the message to ID cannot be 123. And if that is not the case, if the ID is something else, we're going to respond with single job. Now, before we continue, we need to import bad request error. So at the top of our file, we're going to have const bad request error, and we're going to require it from the errors folder. So now we can save our file and head to Postman. So now if we pass in an ID other than 123, let's pass in ABC. And if we send a get request, we get single job. But if we pass in 123, and if we send a request, and if we look at our response, we can see that we have our custom error handler, which is going to send back our message, and it's also going to set the status code to 400 bad request. The next part of our project is going to be setting up MongoDB. If you haven't seen the previous videos, I'm going to show it to you again in this video. So we're going to open up our browser, and you're going to search for MongoDB Atlas, and you're going to open the first link. If you haven't created an account yet, you're going to click on Get Started. If you already have an account, you're going to click on Sign In. If you sign in, you're going to be met with this page. If you're creating a new account, you're going to be asked to create a new cluster. All you have to do is choose the free option and create your cluster. And once you're at this page, there are two things we need to set up. The first thing is database access. In here, you're going to create a new database user, and you're going to give it the following permissions, which is read, write any database, and you're going to save the username and password. The second thing you need to set up is the network access. In here, you're going to create a new IP address, and you're going to pass in the value 0.0.0/0, or you can also choose the option that says access from everywhere. Once those two are set up, you need to get your Mongo URI. In order to get that, you're going to head back to your cluster, and you're going to click on Connect, and you're going to choose drivers. And if you scroll down, you're going to see a connection string. So we're going to copy this, and we're going to use it in our code. Back in our code, we're going to create a new folder, and we're going to call it DB. And we're going to create a new file called connect.js. Now to connect to the database, we're going to use the Mongoose package. So the first thing we need to do is import it. Next, we're going to define a new function called connectDB, which is going to take in a URL as an argument. And what this function is going to do is it's going to call mongoose.connect, and it's going to pass in the URL. Now this function is going to be an asynchronous operation, so we need to define the connectDB function as async. And inside the function, we're going to return mongoose.connect. Finally, we're going to export this function using module.exports, and we're going to pass in connectDB. Before we head to index.js, we need to store our MongoDB URI that we copied. We can't simply store it in our code. That is because it's going to contain our password, which is sensitive information. And when we want to store sensitive information, we're going to use the .env package. So inside our backend folder, we're going to create a new file called .env. And in here, we're going to pass in key value pairs. In our case, we're going to pass in Mongo URI. And we're going to have an equal sign, and we're going to pass in the value that we copied from the MongoDB Atlas website. Now in here, there's a couple of things we need to set up. In between the slash and question mark, we can provide our database name. In our case, we're going to call it job tracker. The second thing you need to do is instead of DB password, you need to put in your actual password. And once you've put in your password, you're going to save this file and head back to index.js. Now in here, in order to use our environment variables, we need to require the .env package. And we're also going to call the config function. Once we've configured our .env package, the next thing we're going to do is define a new function called start. And it's going to be an async function. The reason we're defining this function is that we want to connect to the database before we start our server. Now, since we have async operations, we need to define a try-catch block. Now, you may be wondering, since we defined the express async errors, we said we don't need to define try-catch blocks, but that is only going to apply if we have a request-response cycle. But in our case, since we have a normal function, we're going to have a try-catch block. So first, we're going to await for the connectDB function. And for the URL, we're going to access our environment variable. To do that, we're going to have process.env dot, and we're going to pass in the name of our variable. In our case, it was Mongo URI. And only once we've connected to our database, we want to call the app.listen function. And if we have any errors, we're going to have a catch block, and we're simply going to log the error. Before we call the start function, we need to import the connectDB function. So we're going to have connectDB, and we're going to import it from the DB folder and the connect file. Now at the bottom of our code, we can call the start function. So now we're going to save our file and we're going to look at our terminal. As you can see, we get server is running. This means that the database first successfully connected. Then we got the message server is running. The next section we're going to be working on is user authentication. The first thing we need to do is create a user model. So we're going to create a new folder and we're going to call it models. Again, we're going to have two types of models. The first is going to be for a user and the second is going to represent a job. So the first one we're going to have is going to be user.js. So to create a model, first we need to import the Mongoose package. Next, we need to create a user schema. So we're going to have user schema. And we're going to have a new instance of mongoose.schema. Now this function is going to take in an object of the different attributes that are related to a user. So the first attribute is going to be name. And the type is going to be string. You can also have other validations like required. So this is going to make the name attribute required. And for the value, we can actually pass in an array. And the first is going to be the value. In our case, it's going to be set to true. So required is going to be true. And the second element is going to be the error message that's going to be displayed if the name is not provided. In our case, we're going to have please provide name. Another validation we can have is max length. Again, we can set this to an array. The first is going to be the actual value. In our case, we're going to give it 50. And the error message is going to be name exceeds maximum characters allowed. The second attribute we're going to have for a user is going to be email. Again, the type is going to be string. Now, to make sure that the user provides a valid email address, one option we have is using regular expressions. So we're going to give it a pattern, and our schema is going to check if what the user entered matches the pattern that we provide. So in order to provide this functionality, we're going to have the match validation. Again, we're going to give it an array. The first value is going to be the pattern that we want to match. And the second value is going to be the error message, which is going to be please provide a valid email. Now for the pattern, you don't need to memorize it. So what you can do is simply Google an email validation regular expression and you can copy and paste it. And if you want to use the one I'm using, you can access it in the full code in the description below. Once we've defined the match validation, another validation that we want to apply is that each user should have a unique email address. In order to do that, we're going to have unique and we're going to set it to true. And the final attribute we're going to define for a user is going to be its password. Again, the type is going to be string and it's also going to be required. So we're going to pass in an array and the error message is going to say, please provide password. We also need to provide this required validation for the email. So we're going to copy it and paste it in. And instead of password, we're going to have email. And now we can save this file. Now for the password, currently we're going to store the password as it is, but later on we're going to use the bcrypt package to hash our passwords. Once we've finished defining our schema, we're going to have module.exports and we're going to create a model and we're going to call it user and we're going to pass in our schema. So this is going to represent a user in our database. Next, we're going to go to the login and register controllers. So the simpler one is going to be the register controller. So we're going to work on that one first. So how the register controller is going to work is the user is going to provide their name, email, and password inside their request, which we're going to extract from the request.body. And using that object, we're going to create a new user using our model that we just created. And once we've created a user, we need a way to authenticate that user or to give them permission to access our jobs routes. And to do that, we're going to use JSON Web Tokens. We've seen JWTs in depth in the previous video. So if the user has a valid JSON Web Token that we generated, then that means the user is registered and can access the different job routes. We're going to set up that functionality later on, but for now, we're going to create the new user. The first thing we need to do is import our user model. And we're going to create a new variable called user. And we're going to have user.create. And we're going to pass in request.body. Now there are two things we need to add here. The first thing is that user.create is an asynchronous operation. So we need to define our register function as async. And we need to await for user.create. Again, we don't need to use a try-catch block since we're using the express async errors package and we're dealing with a request response cycle. The second thing is in order to access request.body, if you've seen the previous videos, we need to use an express middleware. So to apply that middleware, we're going to head back to our index.js file and above our routes, we're going to have app.use. And the name of the middleware is express.json. So we can save this file and head back to our authentication controller. Once we've created a user, we're also going to give them a JSON Web Token. Now in previous videos, we defined the code for creating a token inside our controller functions. But in this video, we're going to do something a bit different. We can actually create an instance method that is going to create a token for each user inside our user schema. So to do this, we're going to head back to our models file. And since we're going to be using the JSON Web Token package, we're going to first import it. And we're going to head to the bottom of our code before our export statement. And here to define an instance method, we're going to have our schema name, which is user schema. Then we're going to have dot methods followed by another dot, and we can give our instance method whatever name we want. In our case, we're going to call it create token. And we're going to set this equal to a function. There is a reason why we're not using the arrow syntax, and we're going to see why that is. Now inside this function, we're going to sign a new token. So we're going to have jwt.sign. Now this is going to take in 3 arguments. The first is going to be the payload associated with the token. Now the payload is going to be an object. So we're going to have user ID, and for the value, we can actually access the ID associated with the user using this ._ID. So this is why we used the function keyword to create our function. When we use the function keyword, this is going to represent the current object, or in our case, the current user. But if we use the arrow syntax, it's going to have a different behavior with the keyword this. So we're going to use the function keyword to define our function. So this is going to be our payload. The second argument is going to be our JWT secret, which we have not defined yet. Now previously, we simply passed in the string JWT secret, which is not secure. In order to get a secure encryption key, we're going to open up our browser and we're going to search for 256-bit encryption key generator. And the one I'm going to be using is going to be generaterandom.org. And in here, we're going to press on generate encryption keys. And we're going to copy the key that they give us. And we're going to head back to our code. Now, since the encryption key is going to be private information, we're going to store it in our .env file. So you're going to head to that file, create a new variable called JWT_secret. And for the value, you're going to paste in the encryption key that we just copied. Once you do that, you can access the encryption key using process.env dot the name of the variable, which in our case is JWT secret. And finally, we're going to provide an option which sets its expiry date. For now, we're going to set it to 30 days. So this is going to create our new token. We're simply going to return the token that's being created from this instance function. Now, once we've defined an instance function, we can use it once we've created our user. So we're going to head back to our authentication controller. And in here, after we've created a user, we can call the user.createToken function. And the token that's being created, we're going to store it in a variable called token. And finally, once we've finished getting the token and registering the user, we're going to send back a response, which is going to have a status. And we're going to use the status codes package. And it's going to be a status code of success, which is going to be okay. Before we continue, we actually need to import the status codes. So we're going to have const status codes, and we're going to import them from HTTP status codes. And we're going to have a JSON response. Now our response is going to contain the name of the user, which we can access using user.name, and the actual token that we created. So this is how the register controller is going to work. The user is going to send their name, email, and password. And if they pass the validation that we provided inside our schema, then a new user is going to be created, and it's going to be provided a new token. And later on in our front end, we're going to check for the existence of this token. And if this token is valid, the user is going to be able to access the different routes related to jobs. In our case, we're going to use the token for another functionality as well. Since the payload is going to contain the ID of the user, we're going to be using that payload to display the jobs that are related only to that user. So we're going to use the user's ID to extract the jobs related to that user. So we're going to see this later on. The next functionality we're going to work on is the login controller. The function again is going to be async. And the first thing we're going to check for is if the user has provided an email and a password. So we're going to extract the email and password from the body. So we're going to have a simple if statement that's going to check if email and password is provided. So if there's no email or if there's no password, we're going to throw a new error, which is going to be bad request, which we defined previously. And for the message, we're going to give it, please provide email and password. So this is going to pass this error to our error handler, and it's going to send the appropriate response. And once we check that the user has provided an email and password, The next thing we need to do is try to find the associated user in our database. To do that, we're going to use user.find1. And the criteria we're going to use is going to be the email, since in our schema, we stated that the email is going to be unique for each user. So we're going to pass in the email. Now again, we're at another crossroad. We need to check if the user is not defined. That means the email that the user provided is not associated to any user that's inside our database. So in order to check, we're going to have not user. And if that is the case, we're going to throw a new error, which is going to be unauthenticated. And the message is going to say invalid credentials. Before we continue, we actually need to import these errors. Okay, so once we found the user associated with the email that the user provided, the next thing we need to do is compare the password that the user entered to the password we have in our database. Now, as we said in the beginning of the video, we're not going to store the user's password directly. Instead, we're going to hash the password. So this is always a good practice, not to store passwords directly in your database. Now, to achieve this functionality, we're going to head back to our user model. A concept that we have not seen in this playlist before is that we can define middlewares inside our schema. So in our case, we're going to have a middleware that is going to run before the user is stored in our database. So before we store the password directly in our database, we're going to first hash it, then we're going to store it in our database. So to define this middleware, we're going to have user schema. Since we want to store this before the user is added to the database, we're going to have pre, and the action is going to be save. So this middleware is going to run pre-save. That means before the user is saved in our database. And the second argument is going to be a function. It's going to be async. Again, we're going to use the function keyword since we're going to be accessing the this keyword. And since this function is a middleware, it's going to take in next as an argument to pass control to the next middleware. And here, to encrypt a password, we're going to have two phases. The first step is going to be generating a salt. Now, the salt is going to be a random string that is added to the end of a password before hashing it. So what this is going to do is, even if two users have the same password, since they're going to have different salts, the hash password of the two users are going to be different. So first, we're going to define our salt. And to encrypt our password, we said we're going to use the bcrypt.js package. So we're going to first import it, and we're going to store it in a variable called bcrypt. But the package name is actually bcrypt.js. And inside our salt variable, this is going to be an async operation. So we're going to have a wait, and we're going to call bcrypt.gensalt. And it's going to take in an integer. And this integer is going to represent how many rounds of random values are going to be generated. We're simply going to pass in 10, which is secure enough. And once we've generated our salt, the next step is going to be hashing our password. So one thing to note about hashing is that it's unidirectional. This means that once we've hashed our password, we cannot get the original password back. So what we're going to do is we're going to have this dot password, and we're going to set it to await bcrypt dot, the function name is hash, and it's going to take in two arguments, the original password, which we can access using the this keyword, and the second argument is going to be the salt. So once we've hashed the password, we're going to call the next function since we want to pass control to whatever comes next. Now, one question might arise here. Since hashing is unidirectional, and once we've hashed our password, we cannot get the original password, how are we going to compare whatever the user enters to what we have in our database? So the technique that we're going to use is we're going to hash both passwords. So we're going to hash the one the user enters and also the one stored in our database. And then we're going to compare the two hashed passwords. So we can actually define the functionality here in our schema. So we can have user schema, and we're going to define an instance method. So we're going to have dot methods, and the method name is going to be compare passwords, and we're going to set it equal to a function using the function keyword. And the function is going to take in a password as input. So this password is going to be the one the user enters when they try to log in. And in here, we're simply going to return. Now to compare the hashed passwords, we can use the bcrypt package. So we're going to have bcrypt.compare. And first, we're going to pass in the password that is not hashed. And the second argument is going to be the hashed password, which we can access using this .password. Once we've defined our middleware and our instance methods, we're going to head back to our authentication controller. And in here, we stopped once we found the user using their email. Next, we're going to compare the password that the user entered to log in with the password we have in our database. So we're going to create a new variable called isMatch, and we're going to set it equal to user.comparePasswords, which is the instance method that we just defined. And this function is going to take in one argument, which is the password that the user enters to try to log in. So if the comparePasswords function returns true, that means the email password combo that the user entered is correct, and we're going to log them in. But if isMatch is false, that means the password that the user entered is not correct, and we're not going to log them in. So to set this up, we're going to have an if statement, and we're going to check if isMatch is false. In that case, we're going to throw a new error, which is unauthenticated. And again, we're going to pass in the message invalid credentials. But if it is a match, we're going to create a new token for the user. So we're going to have const token, and we're going to call the instance method createToken. Again, we're creating a token when the user logs in. So this is a pattern we're going to follow. So if the user is a valid user, then we're going to give them a token, which is going to tell us that they are authenticated, and we can give them access to the different job routes. So once we've created our token, we're going to have a response, and the status code is going to be OK. And we're going to have a JSON response. And again, we're going to give them the name of the user and the token we created. Before we continue, we actually need to wait for the comparePasswords function, since bcrypt.compare is an async operation. So this is going to be it for our login and register controllers. So what we can do now is head to Postman to test out each route. So the path we're looking for is going to be /API/v1/auth. So the first controller we're going to test is going to be the register controller, and we're going to send a post request. Before we send our request, we need to include a body. So we're going to click on body, we're going to click on raw, and instead of text, we're going to pass in a JSON. So in order to register, we need to provide a name, a password, and an email. So the first thing we're going to test is by not providing all the required values. So for name, we're going to pass in John, and for email, we're going to pass in john@gmail.com, and we're not going to provide a password. So if we send this request, and if we look at our response, we can see that we have an error that is related to a password. So this is the custom error that is being sent by Mongoose when one of its validators fail. So it's telling us that the password has not been provided. So we can see the message that says, please provide password. So now we can actually provide the password. And we're simply going to give it 123. And now if we send the request, and if we look at our response, we can see that the user has been created, and the response we get is the name and the new token. Now to validate that the user has been registered, what we can do is head back to MongoDB Atlas, and we're going to head to Browse Collections. Our database name was Job Tracker, so we're going to open that up, and our collection is called Users. And as you can see, a new user has been added with the name John. And another thing to notice is that the password, we passed in 1234. However, since we are hashing the password that's actually being stored in our database is going to be a random string. So for testing, we're going to create a couple more users. So we're going to have another user called Jack, And another validation we can test is that the email has to be unique. So if we try to create another user with the same email, we're going to get an error. And if we look at the error, we can see that it's related to the email being a duplicate. So instead of john@gmail.com, we can actually pass in Jack and we can send a response. We get status 200 OK, which means the user has been created. We're going to add one more user. We're going to give it a name of Peter. Again, we need to update the email since it has to be unique. And we're going to send the request. So now we have 3 users created. Before we move on to testing the login route, there is one error in our code we need to fix. So we're going to head back to our authentication controllers. So the problem here is that when we call user.find1, since this is an async operation, we need to await for the result. So we're going to save this file and head back to Postman. Now, in order to log in, we don't need to provide a name. We simply need to provide an email and a password. And we're going to change our route to /login. And now if we send this request, we get a status of 200 OK, and we get the name and the token returned. Another thing we can test is if we provide the incorrect password, let's say ABC, and if we send a request, we get 401 unauthorized, and the message says invalid credentials. One last thing we can test is that if we don't provide the password, and if we only provide an email, and if we send a request, we're going to get 400 bad requests, and it's going to tell us to provide email and password. The next thing we're going to work on is how we can protect the job routes. So what we mean by protect is that we only want the user to be able to access the different job routes if they've been authenticated. So in order to achieve this, what we can do is define an authenticate middleware. So what we're going to do is create a new middleware, and we're going to call it Authentication.js. So this middleware is going to run before the user gets access to the jobs routes. The first thing we need is the unauthenticated error, so we're going to import it. The next thing we need to verify that the token is valid is the JSON web token package. So we're going to import it. Next, we can define our authenticate middleware. So we're going to have authenticate. And as we said, a middleware is simply a JavaScript function, and it's going to take in a request, a response, and the next function as input. The first thing we're going to check for is a special header that is going to be attached if the user is authenticated, and the name of that header is going to be authorization, and we're going to store this header in a variable called auth header. So we can access the headers using request.headers, and the header that we want is authorization. So if a valid user is sending a request, so what their header is going to look like is they're going to have an authorization key, and the value is going to be bearer, followed by a space, followed by a token. So the bearer keyword is by convention. It isn't required, but it's a good idea to include it. So that is what a valid user's request header is supposed to look like. So what we're going to do is we're going to check if they have this header. In order to do that, we're going to have an if statement, and we're going to define it if they do not have an auth header, or if their auth header does not start with bearer followed by a space. So if these two conditions are not met, that means the user does not have a valid header for authorization. So we're going to throw the unauthenticated error. And for the message, we're simply going to pass authentication failed. So this is going to check if the header actually exists and if it has the correct format. Now, after we've checked if the authorization header exists and if it actually has the correct format, the next step is going to be checking if the token is valid. So a token is going to be valid if it is a token that we generated. And in order to check, we can use a function inside the JSON web token package. Before doing that, we're going to extract the token. Now, since the authorization header is going to follow this format, what we can do is pass in auth header, and we're going to split it using a space, and we're going to access the second element. So we're going to split it using a space. So we're going to have bearer as the first element and the token as the second element. So we're going to access the token and store it in a variable. Then we're going to have a try catch block. Now in the try block, we're going to verify the token using jwt.verify. And we're going to pass in the token that is attached to the user's request. And the verify also takes in a second argument, which is our JWT secret. So we're going to have process.env.jwt_secret. So this is going to verify the token. And if the token is valid, it's going to return our payload. In our case, if you remember, we set our payload to be the user ID. So we can store it in a variable. In our case, we're going to call it decoded. So if the token is valid, we're going to get the payload associated with the token. And what we want to do in our case is we're going to store it inside the request. So since this is a middleware and it's going to run in between a request and a response, we can actually attach whatever we want to the request. So in our case, we're going to attach to the request a user key. And for the value, we're going to have user ID, and we're going to pass in decoded.user ID. So the payload is going to contain this user ID, and what we're doing here is storing that user's ID inside request.user. Now the reason we're doing this is later on, we're going to use request.user to filter the jobs that have been created by this specific user. So if all this is successful, we're going to pass the control to whatever comes next, and we're going to define our catch block. And if there is an error, we're going to throw an unauthenticated error, and we're going to pass in authentication failed. And finally, we're going to export this middleware. So we're going to have module.exports, and we're going to pass in authenticate. So what this middleware is going to do, to summarize, is it's going to check if the authorization header exists and if it is of the correct format. And if the format is correct, then it's going to extract the token from the header, and it's going to verify that that token is a token that we created using our JWT secret. And this verify function is going to give us the payload associated with our token, which in our case is the user's ID. And we're going to store the user's ID inside request.user. And later on, we're going to use request.user to access the current user's ID. And based on that ID, we're going to give them their associated jobs. So once we've exported our middleware, we're going to head back to our index.js file. And in here, we're going to import the middleware, and we're going to call it auth, and we're going to require it from middlewares and the authenticate file. So when we want to protect a route, we simply apply this middleware. So in our case, we want to protect the job routes. So what we can do is simply pass in an additional argument, which is going to be the middleware. So we're going to pass in auth. So this is going to protect the job routes. So if we don't have a valid token, we won't be able to access the functionalities related to jobs. So before we move on to defining the job controllers, we can actually test this out using Postman. The path we're looking for is /API/v1/jobs. So previously we saw that when we sent a GET request to this address, we got the response that says all jobs. But now if we send this request, we're actually going to get an unauthorized 401 error, and it's going to tell us that authentication failed. That is because we do not have a valid JSON Web Token inside our request. So what we can do is, since we've created multiple users before, we're going to go to /API/v1/auth/login, and in our body, we're going to pass in a JSON, and we're going to pass in a user, which we've created before. So we're going to have email. We're going to set it to peter@gmail.com. and the password that we set was 123. So now we can send a post request. And if we look at our response, we're going to get the name and the token. In our case, we need the token, so we're going to copy this token. And now we can actually send a GET request to the jobs path. So we're going to have v1/jobs. So in order to attach the token that we just got to our request, we're going to go to the headers tab. And for the key, we're going to pass in authorization. And for the value, if you remember, the correct format is bearer, followed by a space, followed by the token, which we can paste in. So now if we send this request, and if we look at our response, we can see that the status is 200 OK, and we get all jobs returned. So this is how our authentication is going to work. The next section is going to be actually defining the jobs controllers. So we're going to head to the jobs controllers. Before we start working, there are a couple of things we need to import. The first is going to be status codes. The next thing we need is our job model, which we have not defined yet. So we're going to head to our models folder and we're going to define our job model. But first we can actually just import it here, /job. So we're going to head to our models folder and we're going to create a new file called job.js, and we're going to import Mongoose, and we're going to define our job schema. The first attribute of a job is going to be the company. So we're going to have company. The type is going to be string, and it's also going to be required. And for the error message, we're going to say, please provide company. We're also going to give it a max length. We're going to set it to 50. The second attribute of a job is going to be position. Again, the type is going to be string, and it's also going to be required. And the error message is going to say, please provide position. And for the max length, we're going to pass in 100. The third attribute is going to be status. So this is going to say pending, declined, or interview. So the type is going to be string. And we're going to use an enum, which is going to state the allowed values, which in our case are going to be interview, pending, and declined. And we're also going to give this attribute a default value. So when the user adds a new job, by default, it's going to be pending, but they can change it later on. And the final attribute we need to provide is very important, and it's called created by. So this is what's going to associate a job with a user. So in order to do that, the type is going to be of mongoose.types.objectID. So the type is going to be an ID, and we're also going to reference the user model. So we're going to have user, and we're also going to make it required. So what this attribute is going to do is it's going to link a job with a specific user. So later on in the front end, when we list out the jobs associated with a user, we can actually use their ID to filter out the jobs in our database. And finally, we can also have timestamps, and we can set them to true. This is going to contain information when the job was created, and we can use this information to sort our jobs later on. And finally, we're going to export our model. So we're going to have mongoose.model, and the model name is going to be job, and we're going to pass in the job schema. So once we've defined our schema, we can head back to our jobs controller. One more import we need is going to be the not found error, which we're going to throw if the user tries to get a job that does not exist. So now we can start working on the controllers. So the first one we're going to work on is the get all jobs. Since we're going to have async operations, we're going to define it as async. Now before we get all the jobs, we need to actually get the user's ID, since we need to get all the jobs associated with the logged in user. Now if you remember, inside the authenticate middleware, we set request.user to contain the ID of the currently logged in user. So we're going to use that to filter our jobs. So we're going to extract user ID from request.user. Then we're going to have const jobs, and we're going to use our model, and we're going to use the find function. And for the criteria, we're going to check if created by is the same as the currently logged in user's ID. And one more thing we can do is sort the result using the created@at property, which is created automatically when we include timestamps. So this is going to get all the jobs that is associated with the currently logged in user. So once we have that, we can simply send a response using status code OK. And we're going to have a JSON response. And the first value we're going to send back is going to be a count of the number of jobs associated with that user. We can get this value using jobs.length. And the second value is going to be the actual jobs. So that is going to be it for our get all jobs controller. The second controller we're going to work on is getting a single job. Again, here we're going to need the user's ID. So we're going to get it from request.user. Now to get a single job, we need the ID associated with that job. So we need to extract it from the parameters. So we're going to have an ID parameter, and we're going to extract it from request.params. Now we can actually rename this to be more descriptive. So we can pass in job ID. So this job ID is going to actually be extracted from our route. And once we have the user and the ID of the job, we're going to create a new variable called job. And we're going to use the function job.find1. And the criteria is going to be the created by property should be the user ID that is logged in. And also the ID of the job, which is _ID, should be the job ID inside our route. Again, we need to define this function as async, and we need to await for the find1 function. Also in the get all jobs, we need to await for job.find. And once we have the job, there are two things that can happen. Either the job exists or it doesn't. So if the job does not exist, we're going to throw a not found error. And we're going to pass in the message job not found. But if the job is found, we're going to send a response with a status of OK and a JSON response of the job. The next controller we're going to work on is creating a new job. Again, to create a new job, we're going to need the user's ID, which we can get from request.user. Next, we're going to create the job. So we're going to have const job, and we're going to use the job.create function, which is async. So we're going to await, and we're going to define the callback as async. Now to create a job, all the attributes of a job, like the company, position, are going to be passed in by the user, and we're going to get it using request.body. One more thing we need to update is that instead of directly passing request.body, we actually need to modify it. Since the job schema requires a created by attribute, we're going to define it here. So we're going to have request.body.createdby, and we're going to pass in the user ID we get from the JSON web token. And finally, if the job is created, we're going to send a response. The status code is going to be created, and we're going to return a JSON of the newly created job. The next path we're going to work on is update job. Now this is going to be similar to getting a job, so we're going to copy that code. And we're going to define the update job function as async, and we're going to paste in our code. So there are a couple of things we need to change. Instead of find1, we need to call find1 and update. And the find1 and update function takes in an additional argument, which is going to be the updated values, which we're going to access using request.body. Now, if you remember from our previous videos, to get the correct response, we actually need to provide more options. So these options are going to be the new option. We're going to set it to true. What this is going to do is the job that we're going to get in the response is going to be the updated job. And the second option we need to provide is run validators. And we need to set it to true. So this is going to make sure that the update matches the validations we have in our schema. So this is going to be it for the update job controller. The final controller we need to define is the delete job controller. This is also going to be similar. So we're going to paste in our get job code. We're going to define the function as async. And instead of find one, we're going to have find one and delete. And in this case, we're actually not going to respond with the job. We're simply going to respond with a status of OK. And we're going to send an empty message. So this is how the delete job route is going to work. Now, before we move on, we're going to test out each route inside Postman. Now, before we test the routes, we actually need a JSON web token since the routes are protected. So we're going to log into one user. So we're going to go to /API/v1/auth/login, and we're going to provide a body, and we're going to log into the John user. So we're going to have email, which was john@gmail.com, and the password was 123, and we're going to send a post request. Now we should get our token in the response. So we're going to copy this token. And now what we can do is go to our headers, and we're going to define an authorization header. And we're going to give it bearer followed by the token. And now we have access to the jobs routes. So the first one we're going to test is creating a new job. So we're going to go to /API/v1/jobs, and we're going to provide a body. So the things we need to provide are company. We're going to give it meta. We also need to provide the position. We're going to give it intern. We don't need to provide the status since that is going to use the default value. So we can send this request. And if we look at our response, we can see that a new job has been created and the status is pending, which is the default value. We also set the created by property. So this ID is going to be associated to the John user. Again, we can create another job. Let's change the company to Google and send the request. So it's going to create a new job with all the default values. So the jobs we've just created are associated to the John user. So what we can do is send a get request, and we can get all the jobs. As you can see, the count is 2, and it's going to contain the jobs that we just created. Before we head to another user, we can also test the update path. In order to update a specific job, we need to get its ID. So we can copy the ID from here, and we can pass it in our address. Now this ID is for the company meta and the position intern. So what we can do is inside the body, we're going to update the company. Instead of meta, we're going to pass in Facebook, and we're going to send the patch request. Now, if we look at our response, we get a status of 200 OK, and we get the updated job returned. We can also test the delete route. So we can have delete, and we're going to delete the job we just edited. So we're going to send this request. Now the delete route is not going to send back anything since we set our response empty, but we know that it is successful since the status code is 200 OK. To verify, we can go to /jobs and send a get request. And if we look at the response, as you can see, count is 1. Now the next thing we're going to test is what if we have a different token associated with a different user. So in order to test that, we're going to send a post request to /API/v1/auth/login. And we're going to log in as Peter. So we're going to have email set to peter@gmail.com. And the password was 123. So if we send this post request, we're going to get a token, which we're going to copy. And we're going to update our headers. So we're going to change the token, which was associated with John, and we're going to paste in our new token, which is associated with Peter. So now if we send a GET request to get all these jobs, and if we send this request, and if we look at our response, we get 0 jobs, since the job we created is actually associated with John. Now to create a new job associated with Peter, we can send a post request, and inside the body, we're going to pass in the company. We're going to set it to X, and for the position, we're going to pass in front-end engineer. And if we send this request, and if we look at our response, we get that the job has been created. And now, if we send a GET request to all the jobs associated with Peter, we can see that the count is 1, and we get the job that we just created. So this is how we implemented the JSON Web Token. We're using the token to get the currently logged in user's ID, and using that ID, we're displaying the different jobs only associated with that user. So that is going to be it for our backend. But before we move on to the front end, there's one more package we need to use. So we're going to head back to index.js. So the package we need to use is the cores package. So we're going to first import it. And we're going to pass it to app.use. And we're going to pass in cores. So as we said, this package is going to make our backend accessible to our front end. If we don't include this package, we might get errors related to cores policy. So this is going to help us get around those errors. So once we save this file, we can move on to the front end. As we said in the introduction of the video, for the front end, we're going to be using React. So to initialize our React project, we're going to run the command npm create, and the tool we're going to use is going to be Vite, and we're going to use the latest version. And for the folder name, we're going to pass in frontend, and we're going to have ---- template, and we're going to pass in React. Once that's done, we're going to navigate to the folder using the cd command, and we're going to install the dependencies using the npm install command. Once that's done, we're also going to install additional dependencies that we're going to use for this project. So we're going to have npm install. The first package is going to be Axios. We're going to use this library to send requests to our backend. And the second package is going to be React Router DOM. And we're going to use this package to set up different pages in our application. Once that's done, we're going to head to our file structure, and we're going to delete the unnecessary files, and we're also going to break down what each file does. So the node modules folder is going to contain code of our dependencies. Then we have the public folder. This is where we place assets that are going to be publicly available in our application. In this case, there's an SVG for Vite, which we're not going to use, so we can delete it. Next, we have the source folder. This is where the majority of our code is going to get written. Inside the source folder, we have the assets folder. Again, this contains an SVG for React, which we're not going to use, so we can delete it. Now in the assets folder, we're going to add 2 images, which we're going to use in our application. And if you want access to those images, you can get them in the description below inside the full code. Next, we have app.css, which we're not going to use, so we're going to delete it. Next, we have app.jsx, which is the point where all our other components are going to meet. It's going to have some default code, which we're going to remove and save our file. Next, we have index.css, which we're not going to use, so we can delete it. Then we have the main.jsx file. This file is going to be responsible for rendering our components to the index.html file, which we're going to see next. Now in here, we can remove some statements. For example, we don't have the index.css file anymore, so we can delete this line. We're also not going to use strict mode, so we can remove this line. And in our render function, we can remove strict mode. and we can save our file. The next file we're going to look at is the index.html file. So in here we have a div with an ID of root. So this is where the main.jsx file is going to mount our component. While we are here, we're going to modify the index.html file. The first modification is going to be changing the title. So we're going to have job manager. And the next thing we need to set up is Bootstrap. So Bootstrap is going to have a CSS part and a JavaScript part. For this project, we're going to use both. So we need to include a link tag and a script tag. Now you can find these tags in the description below. So I'm going to paste them in. Once we've pasted in our link and our script tag, the next thing we're going to modify is the icon. Now I've already included the two images in our assets folder. So I'm going to use one of them here. Instead of image/svg, we're going to have image/png. And the location is going to be inside the source folder and inside the assets folder. And the file name is letterj.png. So this is going to be the setup for our index.html file. So we can save this and move on. Before we start working on our components, we're going to set up the different pages our application is going to have. And we're going to set this up inside the source folder. And we're going to create a new file called router.jsx. And in here, we're going to use the package that we installed, which is the React Router DOM package. And the function we're going to be using is the create browser router function. And we're going to import it from React Router DOM. Now later on, we're going to import all our components inside this file. But for now, we're simply going to set it up. So we're going to have a router. And we're going to call the create browser router function, which is going to take an array. And each object in this array is going to represent a specific path. So the first path we're going to have is going to be the root of our application. And when the user goes to this path, the element that we want to render is going to be the app component. The second path we're going to define is going to be for logging in. So we're going to have /login. And the element we're going to render is the login component. Again, we haven't defined this component yet, but we're going to define it later on. The next path we're going to have is going to be for signing up a new user. So we're going to have /signup. And the element we're going to render is the signup component. The next path we're going to have is for the dashboard. This is where the user can see all their jobs listed and where they can edit their jobs. The path is going to be /dashboard. But for the element is going to be a bit different. Now the above paths we defined are not going to be protected. Anyone can access them, but the dashboard path is going to be accessed by authorized users only. So in order to implement that functionality, what we're going to do is for the element key, the value we're going to provide is going to be a protected routes component, which we're going to create later on. And inside this component, we're going to have our dashboard component. So in order to access the dashboard component, first we would have to go through the protected routes component. And inside this component, we're going to have a validation check, which is going to make sure that the user is authorized. The next path we're going to have is going to be to update a single job. And the path is going to be /jobs. And we're going to have the ID of the specific job. And we're going to have /edit. And for the element, again, since this is going to be accessed by an authorized user, we need to use the protected routes component. So we're going to have protected routes. And inside the protected routes, we're going to have our update job component. Now the final path we're going to define is if the user goes to a path that we have not defined. And we can represent this using the asterisk character. And the element we want to render is going to be the not found component. Now all these components we have not defined yet, but we're going to define them in the next step. Once this is done, we're going to go to the bottom of our file and we're going to export our router. And we're going to save this file. And we're going to head to our main.jsx file. Now, as we said, this file is responsible for rendering our component to the index.html file. But currently it's rendering the app component. But in our case, we wanted to use the router that we just created. So what we're going to do is remove the import for the app component, and instead we're going to import our router. We're also going to need another component from the React Router DOM package. So we're going to import router provider from React Router DOM. Once we have this component, we can use it to apply our different routes. So what we can do is inside the render function, instead of the app component, we're going to use the router provider component, which has a router prop. And for this prop, we're going to pass in the router that we just created. So this is going to allow our application to be navigated to different pages that we set up in our router. So we can save this file. And next, we're going to start working on our components. Now for this project, when it comes to the components, we're not going to be writing the code from scratch. Instead, we're going to be copying and pasting the component, and we're going to break down the parts that are important. This is because we're going to use a lot of redundant Bootstrap classes to set up our user interface, and breaking down each class is going to take a lot of time. So instead, we're going to focus on the functionality of each component, and if there are some unique Bootstrap classes that we're using, we're going to break them down as well. Again, to access the code, you can find it in the description below inside the full code. So we're going to head to our app component. So there's nothing new in our app component. We're simply importing two other components, which are the navigation bar component and the landing page component, and we're simply returning them. Next, we're going to look at the navbar component and the landing page component, which we have not created yet. So we're going to create them now. Inside our source folder, we're going to create a new folder called components. And in here, first, we're going to work on the navbar component. So we're going to have navbar.jsx. So in our navbar component, we've imported the link component, which is part of the React Router DOM package. And the link component is similar to an A tag in HTML, but what makes it different and more efficient is that when we're using an A tag, our page is going to reload. But when we're using the link component, our page is not going to trigger a reload. So it's going to make it more efficient. Our second import is the logo of our application, which we have in our assets folder. And inside the navbar, we have a bunch of Bootstrap classes that is going to set up our user interface. Now, if you're curious about the different classes, you can look them up in the Bootstrap documentation. But the functionality that is a bit different is going to be how our navigation reacts on smaller screens. So in our application, what we want to do is the navbar is going to contain the logo of our application and two buttons, a sign up and a login button. But on smaller screens, what we want to do is move those buttons inside a hamburger menu. So right here inside our return statement, we have a button, and inside the button, we have the toggler icon, which is the hamburger icon. And what makes this button different is these two properties. So we have data-bs-toggle, which we set to collapse. Then we have data-bs-target, and we've provided an ID. Now, if we look for this ID, we can see that we have a div with an ID of navbar nav. So what this means is it's going to link the hamburger menu with this div. So what this means is on small devices, instead of displaying the buttons, we're going to have the hamburger menu. And inside the hamburger menu, we're going to have the div that contains our buttons. So that is the Bootstrap functionality that's a bit different. And inside the buttons, we're not actually using a button tag. Instead, we're using the link component, which we said is more efficient. And the link component is going to have a toProp. And inside this toProp, we're going to put in a path. Now we've defined a sign up path in our router. So when we click the sign up button, it's going to take us to the sign up component. And when we click on the login button, it's going to take us to the login component. And that is going to be it for our navigation bar. And the next component we're going to work on is the landing page component. So inside our components folder, we're going to create a new file and we're going to call it landing page.jsx. Inside the landing page, again, we've imported the link component since we're going to have a button. And we've also imported another image from our assets folder, which is the whiteboard.png image, which we're going to use for our landing page. And in here, we've not used any different or unique Bootstrap classes, so you can look them up if you want to. And at the bottom, we're going to have a link or a button that says Get Started. And this button is going to be similar to our sign up button. So it's going to take us to our sign up component. So this is going to be the landing page component. Now to see what we've done so far, we can actually run our application. So inside our front end folder, we're going to run the command npm run dev. Before we head to the browser, there's a little mistake that we need to update. And that mistake is inside our router file. So we're going to head to router.jsx. Now in here, since we've not yet created all these components, we're going to get an error when we try to run our application. So what we're going to do for now is we're going to comment out the components that we have not defined yet. And when we define them, we're going to uncomment them. So excluding the app component, we're going to comment out all the remaining components. And we also need to import the app component. So we're going to have import app from the app.jsx file. So now we can save our file and head to the browser. So this is what the root of our application is going to look like. We're going to have our navigation bar with our logo, and we have the sign up and login button. Then we have some sample text, and we also have a get started button. Now, as we saw on small devices, we're going to have a hamburger menu. So to see this, we're going to minimize our browser. As you can see on a small screen, instead of having the buttons displayed directly, we're going to have a hamburger menu. And when we click on the hamburger menu, we're going to get our sign up and login buttons. So that is going to be it for the root page of our application. So we're going to head back to our code. The next component we're going to work on is the sign up component. So inside the source folder, we're going to create a new folder called pages. And in here, we're going to have components that are going to represent a single page in our application. So we're going to create a new file called signup.jsx. So in our signup component, the first thing we have is an import for the link component and the useNavigate hook from React Router DOM. Again, we're going to use the link component to set up a button that is going to navigate to a different page. And we're going to use the useNavigate hook to navigate to a different page when a certain action is complete. In our case, we're going to use it to navigate when the login form is submitted. The next import is going to be for our logo. Then we have an import for Axios, since we're going to be making requests to our backend. Then we have an import for the useState hook. We're going to use this hook to monitor the errors that occur when signing up. So again, in our component, we've initialized the useNavigate hook. We've also set up a useState for our error. Then we have an event handler, which is going to handle the event when the sign up form is submitted. It's going to be an async function, since we're going to have asynchronous operations like sending a request to our backend. The first thing we're going to do is prevent the default behavior of a form submission, which is going to reload our page. So we're going to prevent that. Next, we're going to extract the data that the user entered, and we can do this using form data. And once we have the data that the user has entered, we're going to send a request to our backend. Now, if you remember, the path a user has to go to register in our backend is /API/v1/auth/register. And this path is going to expect a body, and the body is going to contain the name, email address, and password of the user being created. So we have that in our data object. So we're going to pass that in with our post request. Now we're inside the try block, so everything in here is going to execute if there are no errors. So we're going to set our error state variable to false. And we also know that when we send a post request to the /register route, we're going to get a token inside the response, and we need to store this token somewhere. In our case, we're going to store it in the local storage. So we're going to store the token that we get when we register inside our local storage. And to access the token, we can use the response object, and we're going to access .data.token. And once we've stored our token, what we can do is using the useNavigate hook, we're going to navigate to our dashboard. But if an error occurs, what we're going to do is log the error and set our error state variable to true, which is going to display some error message. In our return statement, we're going to see what that error message looks like. So inside the return, we're going to have a simple form, and we're going to have an onSubmit property, which is going to call the function that we just saw. And here we're using the link component. Inside the link component, we're going to have our logo, and when the user presses our logo, we want to take them to the root of our application. Then we're going to have our input components. The first is going to be used to get the user's name, and we've included the required property since in our backend, the name is required when signing up. The next input is going to be for the email. Again, this is also required, so we use the required keyword. And finally, we're going to have an input for our password. And at the end of the form, we're going to have a sign up button. And we're also going to have another link. And we're going to ask the user if they already have an account. And if they do, they can navigate to the login page instead. And underneath our form, we're going to check for the value of the error state. So what we're doing here is if error is false, we're not going to display anything. But if error is true, we're going to display a div that is going to say email already taken. Now the reason we're displaying this specific error message is that this is the error that we're not handling in the front end. The other errors like the name, the email, and password being required are going to be directly handled by our front end. But the email already being taken is not going to be handled by our front end, but instead is going to be handled by our backend. So we're going to display email already exists. This is going to occur if the user tries to sign up with an email that is already associated with another account. So this is going to be it for our sign up component. Now to see what our sign up component looks like, we need to set it up inside our router. So we're going to head to the router file. And in here, we're going to first import the sign up component, which is inside the pages folder. Then inside our router, we're going to uncomment the path for sign up. And we're going to save this file and head to the browser. Now inside the browser, we get our landing page. And if we press on sign up, we get the form to sign up a new user. Now currently, since we've not set up the dashboard, it's not going to work as expected. But later on, once we've defined the dashboard component, we're going to come back to this component and test the functionality. The next component we're going to work on is the login component. So we're going to head back to our code. So inside the pages folder, we're going to create a new file called login.jsx. The login component is going to be very similar to the sign up component. So at the top, we have an import for the link component and the useNavigate hook. Again, we're going to use the link component to link to another page, and we're going to use the useNavigate hook to navigate to the dashboard once the user successfully logs in. Then we have an import for the logo, an import for Axios, and an import for the useState hook. Similar to the sign up, we're going to have our navigate hook and a state that is going to store the error. And when the login form is submitted, the handle login function is going to get called. Similar to the sign up, we're going to get the information that the user has entered. And we're going to send a post request, this time to /login. And the /login is also going to expect a body. And the body is going to contain the user's email and password. And again, if this is successful, we're going to set our error state to false. And the login route is going to give us a token, which again, we're going to store in the local storage. And we're going to navigate to our dashboard. And if an error occurs, we're going to log the error and set our error state to true. Now the return statement is also going to be similar to the sign up form, but this time we won't have an input for the name of the user. Instead, we're only going to have an input for the email and for the password. And again, we're going to have a link that is going to link to the sign up component if the user does not have an account. And finally, if an error occurs, we're going to display the error message incorrect email or password. Again, this is the only error that we're displaying, since by default, the front end is going to handle the other errors like the password not being provided or the email not being provided. So this is going to be our login component. To see what it looks like, we need to set it up in our router file. So we're going to head to router.jsx, and first we're going to import the login component. Then we're going to uncomment the path for the login component. Now we can save this file and head to the browser. So again, this is our landing page. So what we can do is press on the login button, and this is going to display our login form. Again, the functionality is not going to work since we haven't defined our dashboard component yet. But after we've defined it, we're going to test it out again. And if the user does not have an account and they've navigated to this page, they can simply press on sign up, and this will take them to the sign up page. The next component we're going to work on is the dashboard component. So we're going to head back to our code. Before we define our dashboard component, we're going to create the protected routes component. If you remember, in our router file, the dashboard component was nested inside the protected routes component. So first we're going to define that component. So inside our pages, inside the pages folder, we're going to create a new file called protected routes.jsx. Inside our protected routes component, the first thing we're doing is importing the not found component, which we haven't defined yet, but we're going to define next. And the protected routes component is going to have a simple job. The first thing we need to notice is that we're using the children prop, which is a special type of prop that is used to access the nested components inside protected routes. So in our case, the children prop is going to represent the dashboard. So what this component is going to do is it's going to get the token from the local storage. And if the token is defined, we're going to return the children prop, which as we said is going to represent our dashboard. But if the token does not exist, we're going to return the not found page. So now we're going to define the not found component. So inside our pages, we're going to create a new file called notfound.jsx. The not found component is going to use the link component to navigate to a different page. And what the component does is it's simply going to return page not found. And from this page, the user can navigate to the root of our application by pressing go back to home. So that is going to be it for the protected routes and the not found component. Now, before we move on to the dashboard component, there is one more thing we need to set up. Now, the Axios we've been using so far was used to access the unprotected routes, but inside the dashboard component, we're going to be accessing the protected routes. So to access the protected routes, we need to include the authorization header inside our request. And to automatically include this header when using Axios, what we can do is create our own custom instance of Axios. And to do this, we're going to create a new folder in our source folder called utils. And we're going to create a new file called axios.js. So in this file, we're going to import Axios. Then we created our own custom Axios instance using axios.create. We've also defined a base URL. Now this is going to be useful so we don't have to repeat HTTP localhost API/v1 every time. Instead, when using this instance, we're simply going to have, for example, /jobs or /job/ID and so on. Now the next step is the important step. We're going to intercept the request we send with this custom Axios instance. And what we're going to do is fetch the token from our local storage, and we're going to apply the authorization header to our request, and we're going to use bearer followed by a space followed by our token. Now, if you remember, the authenticate middleware in our backend is going to expect a token in this format. And finally, we're going to export our custom Axios instance. So once we save this file, we can move on to working on the dashboard component. So we're going to head to the pages folder and we're going to create a new file called dashboard.jsx. So inside our dashboard, the first import we have is for useEffect and useState. We're going to use the useState hook to store the jobs inside our backend. So once we fetch the jobs, we're going to store them in a state variable. And we're going to use the useEffect hook to send our initial request. So by using the useEffect hook, we can guarantee that fetching all the jobs is only executed once when our component initially renders. Next, we have an import for the custom Axios instance that we just created. So this instance is going to automatically include the authorization header. Then we have the useNavigate hook and the link component, which we're going to use similar to the previous components. Then we have an import for our logo. And finally, we have an import for a job card component, which we have not defined yet, but we're going to use this component to display a single job. So inside our dashboard component, we're going to have our navigate hook, and we're going to set up our useState to store the jobs associated with the user. The first function we have is an add job function. So inside our dashboard, we're going to have a form to submit a new job. So what the add job is going to do is it's going to get the job information that the user has entered, and it's going to send a post request to /jobs. Now inside our Axios instance file, we used a base URL. That's why we're able to use /jobs directly. If we didn't have the base URL, we would have to define the full path using HTTP, localhost, and so on, followed by /jobs. But in our case, since we have a base URL, we can simply pass in /jobs. Now, if you remember in our backend, this route is going to call the createJob controller function, which is going to create a new job in our backend. And once we've created the new job, we're going to access it in the response variable using response.data.job. And we're going to add this job to our state, which currently contains the jobs associated with the user. So we're going to add the new job to the array, and we're going to update our state to include the new job. And if there are any errors, we're going to cache them and log them to the console. The next function we have is handle logout, which is going to be executed when the user presses the logout button. In our case, what we want to do is remove the token from their local storage and navigate them to our home page. Then we have our useEffect hook. As we said, we're going to use this hook to send the initial request to get all the jobs associated with the user. So inside the useEffect, we're going to have a function called getJobs, which is going to send a get request to /jobs. If you remember, in our backend, this route is going to call the getAllJobs controller function, and we can access all the jobs using res.data.jobs, and we're going to update our state variable. Again, if any errors occur, we're going to log them to the console, and we're going to call the getJobs function. So inside our return statement, we're going to have our logout button, and we're also going to have our form to create a new job. And under the form, we're going to have our job card component, which we're going to give it each individual job associated with that user. And since we're going to have a list of jobs, if you remember, we need to provide the key prop, and we need to set it to a unique value. In this case, we're going to use the jobs ID. So we're going to pass an individual job to the job card component, and the job card component is going to display that job in a card format. So the next component we're going to work on is the job card component. So inside the components folder, we're going to create a new file called jobcard.jsx. Inside the job card component, we have an import for the useNavigate hook, which we're going to use to navigate to the update job component, which we haven't defined yet. And the job card component is going to take in a prop, which is going to represent a single job. And from this prop, we're going to extract the company, position, and status, and we're going to display it in a card format. And inside the card, we're going to have an edit button. And when this edit button is clicked, it's going to navigate to /jobs / the current jobs ID / edit. Now we've seen this path before inside our router file. So this path is going to render the update job component. And since we've passed the jobs ID inside the URL, we can access it inside our update job component. And using that ID, we can send a request to our backend. So the next component we're going to work on is the update job component. Inside our pages folder, we're going to create a new file. And we're going to call it update job.jsx. So inside our update job component, we have an import for link and use navigate, which we've seen before. But here we also have an import for the use params function. Now using this function, we can extract parameters from the URL. And as we saw in the job card, we're going to pass the jobs ID inside the URL. So the first thing we're going to do is extract that ID. Then we're going to have a state to store the current job that we're working with. And we're going to have our navigate hook. So once the user presses the edit button, we're going to give them two options. They can either edit the job or delete the job. So the first function we're going to see is for editing the job. So to edit the job, we're going to have a form, and we're going to extract the data that the user enters in that form. And using our custom Axios instance, we're going to send a patch request to /jobs / the ID of the job. And we're also going to pass in our body. And once we've updated the job, we're going to navigate to the dashboard. And if any errors occur, we're going to log them. The second option the user has is to delete the job. So if they press the delete button, we're going to send a delete request using the ID, and we're going to navigate back to the dashboard. Initially, when this component renders, we're going to have a use effect, which is going to make sure that this code only runs once, and it's going to get the job by sending a GET request using the jobs ID. And we're going to store the job inside our state variable. And from this job state variable, we're going to extract the different properties related to a job, and we're going to use those properties as a default value for our input fields. So inside our return statement, we're going to have a form to edit the job. The first input we're going to have is for the company. So using the state, we're going to set the default value to job.company. The next input we're going to have is for the position. Again, we're going to set the default value to job.position. By doing this, immediately when the user presses the edit button, the form is going to be filled with the previous values, which the user can change and finalize the edit. Then we're going to have a drop down for the status of the job. So we're going to have pending, interview, and declined. And finally, we're going to have our edit button and our delete button. So that is going to be it for all our components. Before we head and test the full application, we need to update our router file to include the update job component and the dashboard component. So we're going to import first the protected routes component. Next, we're going to import the dashboard component. We're also going to import the update job component. And finally, we're also going to import the not found component. Once we've set up our imports, we're going to uncomment the remaining paths, and we're going to save our file. Now, since we're going to be testing functionalities that are going to be sending requests to our backend, we also need to run our backend. So we're going to head to our terminal, and without deleting our current front-end server, we're going to create a new terminal using the plus icon. And we're going to navigate to our backend folder, and we're going to run the command npm run dev. Once we see the message server is running, that means our backend has successfully started and connected to our database. So we're going to head to the browser. So the first functionality we're going to be testing is signing up. So we're going to press on sign up. And for the name, we're going to pass in Abel. And for the email address, we're going to pass in abel@gmail.com. So for the password, we're going to pass in 123456, and we're going to press on sign up. So this is going to send a register request to our backend, and it's going to create a new user. Later on, we can verify this by going to MongoDB Atlas. So initially, we're not going to have any jobs, but using the form, we can add a new job. So for the company, we can pass in Meta, and for the position, we can pass in intern and press the add button. And this is going to send a request to our backend to create a new job. And we can press on the edit button, which is going to take us to the update job page. And in here, we can update the information about the job. For example, we can change the status to interview and press on the edit button. And it's going to navigate us back to the dashboard and it's going to update the status. You can also test the delete functionality. So we're going to press on edit and we're going to click delete. And back in our dashboard, the job is going to get deleted. Next, we're going to check the login functionality. So we're going to log out from this account. Then we're going to press on login and we're going to use an email and password that we created when testing the backend. The email address was peter@gmail.com and the password was 123. Just to test out the error, we can put in an incorrect password and press on login. And this is going to display our error message. And now we're going to use the correct password and press on login. And we get the job that we created when testing the backend displayed. Now the final section of this video is going to be deployment. So to set this up, we're going to head back to our code. The first thing we're going to do is inside our front-end folder, we're going to create a new file called .env. And in here, we're going to set up an environment variable that is going to store our backend's base URL. So the name of this variable is going to be vite_backend. And for the value, in our case, it's going to be HTTP localhost 3000. The reason we need to define this variable is that in the deployment process, we're going to have a different base URL. So inside the deployment software, we're going to pass a different value for this environment variable. For now, we're going to save this file. And the next thing we need to update is wherever we send a request to our backend, instead of having localhost 3000, we're going to use this environment variable. Now to cover off all the protected routes, what we can do is update our Axios instance to use this environment variable. So we're going to head to axios.js. And in here, we're going to remove HTTP localhost 3000. Now to use an environment variable in React is going to be a bit different than the one we saw in the backend. So in React, we're going to have the syntax import.meta.env the variable name, which in our case is vite_backend. And we're going to save this file. Next, we're going to update the unprotected routes, which are the sign up and the login route. So first, we're going to head to the sign up component. And in here, we have a post request. So we're going to change HTTP localhost 3000. And we're going to use the same syntax. So we're going to have import.meta.env.vite_backend. And we're going to save this file. And finally, we're going to head to the login component. And again, we're going to remove localhost 3000 and we're going to replace it with import.meta.env.vite_backend. And we're going to save our file. Now for the deployment, we're going to be using Vercel. So we need to add some boilerplate code to both our backend and our front end. So first in our front end folder, we're going to create a new file called vercel.json. And the contents of this file you can copy from the full code in the description below. So I'm going to paste it in. And next we're going to go to the backend folder and we're going to create a new file called vercel.json. And in here, we're also going to paste some boilerplate code. So that is going to be our setup. Next, you're going to push all the code we wrote in this video to a GitHub repository. As always, before you push every file, make sure that you're not pushing the .env files, which contain your password. And once you've done that, we're going to head to vercel.com. And once you're here, if you don't have an account, you're going to sign up using your GitHub account. And if you already have an account, you're going to log in. Once you're in, we're going to first deploy the backend. So we're going to press on Add New, then Project. Then we're going to search for our Git repository. The repository I saved it on is called job-manager. And it's going to tell you that you need to grant access for Vercel to that repository. So you're going to click on Configure GitHub App. And under the repository access, you're going to add your new repository, which in my case is Job Manager. Then you're going to click on Save. And now you're going to be able to import this repository. As we said, first we're going to be deploying the backend. So we're going to change the root directory to the backend folder. And we're going to click on Continue. And another thing we need to set up is our environment variables. In here, you're going to include all the environment variables we had in our .env file in our backend. Once you've done that, you're going to click on Deploy. Once you get this page that says congratulations, you just deployed a new project. That means our backend has successfully been deployed. So we're going to continue to our dashboard. And from the backend, what we need to extract is the domain. That is because we're going to use this domain in our environment variable for the front end. So we're going to copy this URL. Then we're going to head back to our homepage and we're going to create a new project. Now we're going to be deploying our front end. For the Git repository, we're going to choose the same one. And for the framework preset, we're going to use Vite. And for the root directory, we're going to pass the front end folder. And inside the environment variables, we're going to create a new one for Vite_backend. And for the value, we're going to paste in the URL we just copied, which is our backend's URL. Then we're going to click on Deploy. That means our front end has successfully been deployed. So we're going to continue to our dashboard. Before we test the application, there's one small mistake we need to fix. So we're going to head to the project where we deployed the front end, and we're going to update our environment variable. We're going to head to the Settings tab, then to Environment Variables. Then we're going to edit our Vite_backend. And instead of directly just passing in the backend URL, we're going to add https:// before our backend URL, and we're going to save our environment variable. And to make sure that our changes are applied, we're going to redeploy our front end. And once our application has been redeployed, we're going to open up our URL. And now we're going to test the login functionality. So we're going to click Login, and we're going to put in peter@gmail.com. And for the password, we're going to put in 123, and we're going to click on Login. And as you can see, it logs us in to Peter's account. So that is going to be it for this video. Thank you for watching this video, and don't forget to like the video and subscribe to our channel for more programming content.